All right, let's keep going. And now what we're going to do is talk about how do you graph the basic parent graph for a growth or decay function, and how would you graph it if some things about this basic parent function moved. All right, so I do want to make this disclaimer. This is not the only type of growth or decay equation you can have. It is generally going to be about the same, but if the b value is different, your line can be steeper, or if it is a little bit less than this, it'll be a little bit flatter. So I just usually use these numbers for b when I do these general equations because it usually is good enough and it gives you a better or good enough example of what's really going to happen when you're talking about the key features. All right, so here is an example of a growth equation. Remember, your b value is larger than 1. So we are dealing with some growth. All right, so the b is 2. Now what about a? This number that's out in front there, what could we have multiplied by 2 to the x that wouldn't change anything? 1. And then for a d value, there is not 1 because there is nothing added to this equation. We already decided it's growth. All right, for the y-intercept. Now, this is an example of what the graph already looks like. Remember, the y-intercept is where your graph touches the y-axis, so we're right here. So that would be the point 0, 1. If you are looking at a basic growth equation, y equals 3 to the x, y equals 4 to the x, y equals 10 to the x, these key features will be the same. You're still dealing with y-intercept is 0, 1. And then this next part will still be the same. We briefly discussed what an asymptote is. It is this line that a graph is going to approach, but it will never cross. So, you could zoom this thing out to negative 5,000 on the x-axis, and we're still not going to be touching it. Now, we're going to be really close, but we're not going to get there. So where is this line? It's an equation of a line, and it is horizontal. So that means it's going to start with y equals, and it is passing through what on the y-axis? 0. So y equals 0 is the equation of the horizontal asymptote. Usually I'll refer to it as the HA. Okay, for domain, x-axis. Is there a limit on how far left and right we can go? No. So it would be all real numbers, or you could do your infinities. For the range, on the other hand, there is a limit. All right, vertically, this graph will approach this area, but it's never going to get there. So it's going to get close to 0, but it's never going to actually touch it. So, when we were doing radical equations, we actually used a bracket, but we're going to use parentheses this time because the significance of the parentheses is that we approach 0, we never actually get there. So that is the difference for that. All right, so let's see what decay looks like. I think you're going to see we have a lot of resemblances here. So for the a value, again, there's nothing there to multiply it in front, so it's just a 1. B is a half. D is 0. And we're going to make an observation about this d value here in a moment. So decay, y-intercept, kind of interesting. It's still the same as our other function, but this time we're decaying, not growing. What is the horizontal asymptote? Again, this dotted line, the graph's never going to cross, but it's going to approach. It's y equals 0 yet again. Remember, it was the same way on our previous one. So that's a similarity. For the domain, there is no limit to what x values we can plug in here. There is only a limit to, what's going to happen on the y-axis. So again, domain is all real numbers. For your range, again, the lowest this graph will ever get or approach is 0 on the y-axis. All right, so where else do you see a 0 up here in your A, B, and D info? D is 0, right? So this D value, its significance is it tells you how far the graph is shifting up or down from the original, but it also tells you where that horizontal asymptote is. You'll see an example of that in a moment of how that works. But notice also that 0 shows up here. I wanted a different color. There we go. Here, here, and here. Right? All 3 of those moments are 0. The only difference is your y-intercept is a little bit different this time. So we will adjust and use that to help graph these other ones. But keep those graphs in mind as now we try to do some transformations. And I'll try my best here to fit all of this on the table and then draw a little example down here at the bottom. All right, so for this very first question, what we're going to do is identify, is it growth or decay? All right, so based on what you know, here's your b value. Remember, it's the thing with the exponent on it. It's a 2. That is a growth. Now, for the transformation part, okay, let's do a little thinking here. Do you remember when we did radical functions? If the number added or subtracted at the end of the function was there, if there's a number there, it moves the graph up or down. So if you have a -3, that is a down 3. All right, the y-intercept, not real sure. You know what? Let's just go ahead and do a graph. I could tell you how to do it, but I think visually it'll make more sense if we go ahead and graph. All right, so we're doing a growth. So let's just give ourselves a reminder that we're going to rise to the right here. Now, on the original 2 to the x, we had a horizontal asymptote at 0. But down here, that's not going to be the case, right? So wherever your d value is, that's where your new asymptote is. So go down to -3. And if you want to, you can draw a dotted line through that. And I always do because it's just a good visual boundary that I remember to keep. All right, then when we saw our y-intercept on our other problems, it was at 0, 1. Unless you have a stretch or shrink, your y-intercept will always be 1 unit above your asymptote. 1 unit above. So, and this is growth, and you know what? We're just going to sketch it on there and be done with it. It's a growth shape. The y-intercept is 1 unit above the asymptote, and that's it. So let's just fill all this stuff in. So your y-intercept was 1 unit above that. So that would be 0, -2. What was the horizontal asymptote? It was our d value. So keep that in mind. This is d. Y equals -3. All right, so what about domain? Domain would be, once again, all real numbers on all these. But your range, what are you going to have to do with that? Base your range off of your asymptote. There we go. So that was also your d value, -3 to infinity. All right, let's go ahead and do the second one, and then we'll see if we need to do the other ones. All right, so for number 2, it is a growth not growth, it's the decay. Finally, we have a decay. If you add 4 to that function, you are saying everything's getting bumped up 4. And remember, our equation's going to have this sort of shape. All right, so what I honestly like to do is after I identify those things, I just like to go ahead and draw a graph, because sometimes we may be better at identifying what the parts are after we have it sketched out versus trying to do all that on our head. Remember, originally your asymptote's at 0, but if you move this thing up 4 units, then your asymptote is now at +4. If you wanted to, you could go ahead and hop up here and write y equals 4. All right, then where our y-intercept occurs, it is always 1 unit, unless there's a stretch, 1 unit above that horizontal asymptote. So it will be right here at 5. The only thing you got to do is remember, when you go to draw it, this is decay. So we're going to go this way. We're going to hug that line, but we're never going to cross it. Let's go ahead and do our domain and range. Domain is the same on all these, but the range, again, is based off the d value. So it'll be from 4 to infinity. It won't ever go below 4 on the y-axis. Alrighty, so I do want to show you actually one more, because I want you to see what happens when you do a stretch. All right, so number 3 is that. Number 3 is still going to be growth, because of the b value being 2. But this little 1/2 thing here, remember on the radical functions, if you had a number multiplied by the function, it was a stretch or shrink. This is going to shrink. And it's going to shrink in that it's going to change, it actually will change the y-intercept. All right, now what about the horizontal asymptote on this? Do we have a d value? Actually, we don't. So when we get ready to draw that horizontal asymptote, see there's no like plus here. So that means that the horizontal asymptote does not change from the original. That's kind of nice. All right, I'm going to put a 1 here and a 2 here. All right, so the horizontal asymptote, we could just go ahead and say y = 0. And actually, we could go ahead and fill this in, but we'll wait for that. All right, normally, if it's a growth, it is going to rise to the right, and this one's going to do that too, but here's the difference. When you get ready to plot your y-intercept, normally a is 1. On all these other ones, a is 1. And that's kind of like it kind of gives you a distance from the asymptote as how high you're going to go. But if a is a 1/2, we're only going to go up a 1/2. And I'll show you another reason why too here in a second. So we're doing a growth, and our asymptote is at 0. Our a is a 1/2, so we're only going to go up 1/2 a unit from the asymptote this time instead of a whole unit. So your y-intercept will be at 0, and you can just say 0.5 or 1/2. Domain is the same. Range is from 0 to infinity. All right, let me show you another reason why I know that the y-intercept is going to be at 0, 1/2. The y-intercept always has a 0 for an x coordinate. So if I were to come over here and plug in 0 for x, what's 2 to the 0 power? 1. And what's 1/2 times 1? Remember, you got to do exponents first, so that's why I did that first. Y = 1/2. All right, so hopefully that'll help you get some graphs done.